Okay, so why don't you take a second and try and answer the problem, and then after you have attempted the problem, continue the video, and then we can try and look at it together. Okay, so this is a quantity A, quantity B problem, and you need to determine whether quantity A is larger, whether quantity B is larger, whether they both are the same, or whether it's unknown. So the length of each side of an equilateral triangle T is 6 times the length of each side of equilateral triangle X. That's the information that we're given. Now the definition of an equilateral triangle is that all sides are the same. And in Euclidean geometry, what that means is that basically all angles are 60 degrees as well. This is kind of the definition of an equilateral triangle. But you can have triangles that are larger or bigger that have this. You can have another triangle that's just as large, has 60, 60, 60, and also has equivalent sides. Although these would have to be like this because they're obviously much larger than these. So anyways, that's kind of the idea behind equilateral triangles. So what we have here is we have two triangles, and they actually give us the ratio of one side of one of the triangles to the other side of the triangle. Oy, oy, oy. Let's just assume that these are equilateral rather than what they obviously look like, which is not. And these are all the same, and this is going to be equal to x over here, and this is going to be equal to 6x. Alright, so this is triangle X, and this is triangle T. So let's actually change this. Let's call this A, and let's call this A. So this has length, this side has length A, this side has length 6A, 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 A, and A. So this one would correspond to this one to that one, and this one to that one. And obviously the angles are all going to be the same. They're all going to be 60 degrees. Now, actually, this isn't necessarily that too important. This is kind of just what the picture is going to be looking like. What you're looking for is the ratio of sides to sides. So you want to know the ratio of the length of one side of T, so one side of triangle T, to the length of another side of triangle T. Okay, so that's length to length. Now, the ratio of something x to y is just x over y. So if we're looking at the ratio of 6a to 6a, we're just looking at 6a over 6a, which is equivalent to 1. So the ratio of length of one side of T to the length of another side of T is just going to be 1. Now, if we go over here and we look at the quantity B, the ratio of length of one side of X to the length of another side of X, we're still looking at the same ratio. We're looking at A over A, which is still going to be 1. So the answer is that both of these are the same. So C.